All right, one of them's back. Do you know where Jordan went?
I do not remember, but he did say that he's here.
Yeah, I mean his backpack's still here.
Yep.
Okay. All right, so a couple of things regarding housekeeping and schedule. So we're on the fourth week. One thing that I did was I actually took a section out of this class that has to do with building our own modules and building our own classes. And maybe I'll put that stuff in toward the end, if we get to it. But I didn't actually have that in originally. I put it in last time I taught the course. And so I decided to take it back out. I think it probably fits better at the end anyway. So if you fit it in, we fit it in. But what that means is that today we're going to, and also another thing that we did was actually talk about files last week. So I'll kind of reintroduce that concept or reteach it as we talk about today's topic, which is dictionaries. And because of taking out the stuff on creating our own classes and creating our own modules, I was able to just move the GIS stuff into this week. So we're going to introduce using Python for ArcGIS this week as part of, and then talk about dictionaries as well. Just wanted to make sure here that my audio is working. Yeah, it looks like it's working great. Okay, so that's where we are. It did move the test up a week. So the test in this class, it moved everything up a week. The test in this class will now be on October 15th. It's still a few weeks away, and we'll still talk about what that is before we get there. But today we're on this week 4, which is dictionaries. We're going to introduce external modules just as a concept. We've already used an internal module, which is math. But as we learn about a few other things later in the course, we'll actually start to use these external modules. But I'll do a little demo on why they're cool and like what kind of things they do, and then we'll start using an external module that is that helps us to work with GIS, and it's called ArcPy. There's actually 2 different modules for working with GIS. One's for working with GIS on your computer, and one's for working on what they're starting to refer to as either Web GIS or Enterprise GIS. So we'll utilize both of those, but we're going to start with the one for working with GIS on your computer, which is called ArcPy. So that's what we're going to do today. All right. Just a second. I don't want to hurt my knees. Okay. So the first thing that we're going to do is, and then one more housekeeping thing is, just like my class last Wednesday, I have to leave right after class today. It's not usually I don't have to do that, but I do have to leave around 3 o'clock. So just to let you know. So if you have any pressing questions, get them in when I ask if there's any questions. And just like usual, though, we can talk after class. We can talk over email. All right. Something I was lax on doing was creating turn-in assignments. So now I do have a turn-in assignment for Lab 4. Lab 3's got up a couple days late, but it's there now. So if you haven't turned in your assignments, turn them in. I know this says September 27th, but I'll accept them a few days late because I even put the due date up a few days late. So, all right. So Lab 4 next week. All right. So now we're on to 4, and today we're going to start off talking about talking about one more type of sequence, and that is a dictionary. So what are sequences? When I say sequences, what are some of the types that were sequences that we discussed last week? I'm going to go ahead and start Jupyter Notebook.
Left forward is the one for this class.
What's that?
So left forward is for today.
Lab 4 is today. This is week 4 of this class. One of the things that's confusing for those of you, I know several on the coast are also in my other course, because the semester started on Wednesday. Week 5, tomorrow's course is week 5, but week 4 is this. This is our 4th meeting. That's what I'm trying to say. Okay, so what are some sequences? So we could create a little. Oh, I shouldn't have put it here. I'm gonna delete it. So I'm gonna go into courses, SPA, week 4, and then create a new Python 3 and talk about Actually, I'll just call this Intro to Dictionaries. So we could say something like, what are some types of... Hey, did you guys say something on the coast? Sorry, maybe I need to turn the volume up.
So were you asking for like a sequence operation or a sequence function?
Can't turn my volume up here because you guys are saying something. So it used to be. I heard the question mostly. It's hard to hear, but you ask, are you asking for a sequence operation or a sequence function? No, I'm just asking, what are some types of sequences, like in terms of data? What data types are sequences? What data types are sequences? What's that? Integers are not sequences, but thanks for providing some information. Yeah, what data types are sequences? How about strings? Are string sequences? See if this works. Yep. All right, so this is what we went over last week. So I guess I'm finding out that my teaching methods aren't very good or something. But sequences are made up of elements. So a sequence is as a data type that's made up of different pieces. So an integer is not a sequence because it's just a thing. Like it's one thing. It's a number. There's no sub parts to that that variable, that item. Okay. Some data types are actually made up of other components. There's more than one of them. You can break them apart and look at their individual elements. You can reference them. All right. So what are some of the data types we talked about last week that had that ability? Strings was the first one we brought up, but then we talked about basically 2 others. An array is a good answer, and we didn't really talk about an arrays, but an array is a type of sequence. Tuples is one that we talked about. But a list, right? Lists and tuples.
Would a sequence be a process to get to something, a value? You just can't do one of the things you get to another.
No, a sequence is just a data type.
Okay.
I messed up here. Or something. There we go. I don't know what this is. Let's get rid of that one. All right, so to create a string, we can just type in my string equals thing, right? That's a string. My list, how do we create a list? Yeah, the square brackets, and we just delineate them with commas. So we could say item 1, item 2, and item 3. So how many elements does my string, how many elements are there? No, in my string. No. How do we find out what's the function that we can use to get the length of a list? LEN. Any sequence will give you LEN with any sequence inside will give you the length of that sequence.
Okay.
So I can go like this and get 3. So the LEN function returns the length of any sequence.
So then the items in my list is not going to count their characters. So 1 colon is 1, 7, item 2.
You're asking how long my list, when you say len and my list, you're asking how long my list is. You could, Elvis, ask how long the first item in my list is. How would I do that?
Okay.
So here, I'll just put, how would I ask how long the first item in my list is? Okay, how do I do that? Len 1, like that.
Well, no, you got to identify what you're trying to do. Len 1 in my list.
Like this.
Right. It might work.
Okay, so we get this error. List object is not callable. Remember we another parentheses between the one, like. So we got the right answer up here. Callable means that we're asking for a function. So my list is not a function, it's a list. And so if we want to get an item out of the list, we use the square brackets, not the parentheses. So now this will work. Now, is that the length of the first item in the list, though?
Oh, 1, 2, 3, 4, 5. Yes, it is.
All right, let's test.
You're identifying the first one.
My point is, my list, bracket 1, bracket, is that the first item in the list?
No, it's the second.
Right. So how would we change this to get the first item in the list? Yep, 0. So now we get the length of this guy.
Right.
Yep. All right. So, and this is a tuple, by the way. Tuple has 1, 2, 3. Now, it does sound like some of you have taken a computer science class before, and you've used the term array. One of the big differences between these data types, my list and my tuple, is that all the elements do not have to be of the same data type. You can mix data types, whereas an array, usually everything's the same data type. All right. Oh.
You said a list and a tuple can have
A list and a tuple can, yep. The only significant difference between a list and a tuple is what? We talked about it last week a bit. Well, yeah, you create it with brackets, or you create it with parentheses. That's true, but that's not really a significant difference because everything else you can treat them the same way, except for there's one difference. One important difference, and it's not even then it's not really that important. Sorry, what was that? Nope, tuples can have strings in them too.
Isn't it, oh, I'm gonna butcher this, but, set,
Yep. Mutable.
Mutable.
Yep. Tuples are what they call immutable. You can't change them once you create them. You can't change their individual values. You can reassign a tuple to be a whole different tuple, but you can't reassign them by index. In other words, you can't say, I want to take the first item in this tuple and set it to a new value. You can't do that. You have to say, okay, I want to assign every value in this tuple a new value. I just want to assign it to be a new thing. But yes, tuples are what we call immutable, and lists are mutable. They can be changed. Okay. So here we go. I'll show you what I mean by that. So my tuple, my tuple, how do I get the first item in my tuple? Yep, same way as getting the first item in my list. And then I say equals to 3. But I say my list 0 is equal to 3. Here, I'll put these in 2 different cells. And I'll even write on top. This will cause an error because tuples are immutable. And I'll run it. See, there's an error. And then I'll say, this will not cause an error because lists are mutable. And I'll run that. And I'll print my list after I'm done. Forgot to put a parenthesis around it. And now, see how it says, I've changed the value of the first item to 3. So that is the main difference. Yes, Jordan, you have a question?
I'm confused. Like, okay, so what is it that, okay. Can you say what you were doing again?
Yeah, so I was demonstrating that tuples are immutable. They cannot be changed. Okay, so I can't say that a part of a tuple is going to have a new value. So that's what I was showing here. So I can't say my tuple 0 is equal to 3. It won't work because I can't change that item in the tuple. I can do it in a list. I can say the first item in my list is now going to equal 3. That works. I actually changed it. You can see here. I changed that value. Item 1 no longer, the first item no longer equals item 1. It now equals 3. So we changed its value by this statement. Whereas this statement didn't even run. It caused an error. And the error says it doesn't support item assignment. Now, if I wanted to, I can change the entire value of my tuple, but not individual elements. You can always reassign values. So I could say my tuple equals 3, 5, 12, and run that. Okay. I just can't change individual. What I've done here is I've totally destroyed my tuple and recreated it. You can always do that, but you can't change the individual elements. And so, really, there's no real reason. I mean, there's no really good reason not to use a tuple or a list in any situation. The only difference is if you for sure don't want the values changed. Like when they go into a function, for example, you don't want, and you know you don't want them to be changed, it might help if they were a tuple rather than a list. That's the only reason why you'd want it to do that, so that you know those values can never be manipulated. Sorry, go ahead. Ellis, were you going to ask a question?
Well, I was thinking about what you said. It does make sense because once you say my two, then automatically, you can say my two for one. That's different than my two. So whatever value, whatever have you see my two for one, it would have put a new value that way. It wouldn't change.
Yeah, and I can still print my tuple. Like I can still get the values out of just a particular element. I just can't change them. I can't set them equal to something like I did here. Okay. I'm going to rename this review of sequences. And then I'll just go file new notebook. And I'll call this one Intro to Dictionaries. Okay, so a dictionary is a data type that is dictionary is a data type that is a sequence, but it's indexed differently than other sequences. Sometimes people call them associative arrays. And the way that you create a dictionary is with the little curly brackets. The curly brackets create a dictionary. And instead of being indexed by saying 0, 1, 2, 3 in order, dictionaries are actually indexed by a label that you or whoever created the dictionary gives the label. So, for example, I could do something like this and say George 44 I put it in quotes. Okay, so I've created a dictionary, and my dictionary has 4 entries. Okay, I put the ages of various members of my family in the dictionary. So in a dictionary, there are two items that you have to give it. So it's kind of like a list. So you got to see how the list is separated by commas. Each comma represents an element, just like in a list. So the items in the list are these ones. This is one item. This is one item. But inside of each item, there are two values. One of those values is called the key. In other words, the key is the index, the way to look up the value. The other item is called the value. So this is the key, and this is the value of this item. So we can access. Oh, the first one is the key. The last one is the value. Key value, key value, key value. And they do have to be in that order. So
you say George is the first key. You didn't make a get it, but right now, George is the first key and the second key is fourth key.
right, but you cannot actually access them by order like you can a list. So I can't say I want the second one. It's gonna say that's a key error. There's no two. I have to access them by their keys. So if I want to know Lindy's age, I have to say my dictionary and I have to put in the key, and what it returns out, the value that I get, is the value. So my dictionary, Lindy, returns the value. Yeah, go
So
ahead.
whatever's in quotations is what you're saying?
It actually doesn't have to be quotations. The keys can be any data type, and the values can be any data type. So I could put, instead of Scott, I could write 4, right? And this is still going to work. And then if I said my dictionary 4, then it would return 19. So the keys and the values can all be any data type themselves. But typically, you're right. Typically, we use labels that are strings.
I have another question.
Yes.
So when you have that my dictionary, is that just like a bracket or is that like the squiggly brackets like last time? I can't really see that well.
Yeah. So the beginning and the end are squiggly brackets.
For the my dictionary part. But when you're trying to get what you want.
Oh, yes. All sequences are the same in that regard. You use the square brackets.
Okay. No, I just couldn't see
How
that.
would you know what's in the dictionary? My dictionary, just to know, because you wouldn't know any of that unless you had a reference key.
Right. Like, what if you don't know what all the keys are? Okay. So there is a way to get the keys in a dictionary. You could just say, I'll put this actually down here. My dictionary dot keys. And it will return the keys. Okay.
What about the second portion?
What's that?
Where it's right, you wouldn't need to know the ages here. But so you can use those keys to get the remaining amount that you're looking for.
Yeah, you could use those to get the rest of them. And in fact, look at this. Let's look at the type that this returns. It returns these dictionary keys, but we can actually create a for loop that does every item in a dictionary. So we could just say for my dictionary, for item in my dictionary. Now, item itself, this is just a variable name. Now we could say print item, and now we'll get, oh, sorry, I forgot. I always forget that. Now we'll get just the keys out. I'm pretty sure if we typed in dot keys, we get the exact same thing. Just let me see. I don't know. Yeah. So that's shorthand. So we'll get each of those values out. Now let's think for a minute. What if we wanted to print this number? I think that's kind of what you're asking. We wanted to print the value rather than the key. How could we change this statement so that we got the value rather than the key? In other words, we want to do that inside the print statement. Sorry, what was that?
I was just guessing, but not values instead of dot keys. You want to use the value?
Actually, that might work. That wasn't the path I was. Let's see what happens. Nope, that didn't work, but it was a good guess. This is the convention for doing it in Python. So every time through the loop, item turns into the key. So the first time through the loop, item is George. So what's it going to print? And what's this statement going to print? It's going to look like this same statement. But item turns into George. So what's going to print? What printed here when I said my dictionary George? 44. Yep, all the values in the dictionary will print. See, 44, 12, 15. If we wanted to print both of them, we could. If we just type in item, comma, then we'll print both the key and the value. We could even write it like this, because it might make more sense. You don't have to use the word key, but that might make more sense. Oh, this has got to be key now, though. There we go. That might make more sense. But this is just a variable name. It could be anything. It could be Bill. For Bill in my dictionary, print Bill, my dictionary Bill. It would work the same way. Sorry, were we about to say something?
Why did you change item to key in the brackets after item?
I was just trying to drive home the point that this is just a variable name. It could be anything.
Okay.
Like I could change it back to item. I could also do, you know, JKLO.
So, Frankie dictionary key inside the bracket, they would have printed him as just at this point, that numerical number, first part would be in parentheses, put 52.
I'm sorry, can you ask that question again?
I'll be looking at how you put in brackets, my dictionary bracket, but they would have called up the second part of 44 about putting in brackets.
Well, just like any sequence, when you ask for a element, you use the brackets. And the way that you ask for a dictionary element is you give it the key. Does that make sense?
And the key would be George.
Yeah, so the first time through, the key is George. And so it returns 44, and that's why it prints 44 right here.
Okay.
Second time through, the key is Lindy, and I'm asking for Lindy, and so it gets 12. It prints 12, and so on. The dictionaries are actually called dictionaries because they're the best way to think about them is kind of not the best way. Sorry, the original way to think about them was, let's say we have well, they're kind of like, you know, real dictionaries. You can use them to look up values. So how about, I'll just call this into Spanish. Right? I'm not very good at spelling in English or in Spanish. Anyway, I don't need any more examples. All right, so you could have strings on both ends. And then say, you could write like,
Yeah, put HOLA,
H-O-L-A. Oh, you're right. H-O-L-A. Now it's going to print hello. Right? So if you had a whole dictionary full of words that were in Spanish, you could feed it an entire string. Like, I could say, did I mess that one up? Oh, there we go. All right. I don't even know the words for. Anyway, it's kind of a silly example, so I won't follow it through. But I could I could go through word by word and try to translate that. Of course, it wouldn't really translate. But the point is that that dictionaries associate one concept with another concept, so you could reference them by the key and get the value. Yeah.
So for
Can
instance,
you take a database line and translate it into a dictionary itself? You know, like they have like the other person.
Yeah. So the whole reason that we're talking about dictionaries is because later, when we interact with things like a database line, one row of a database will be returned in something that's either a dictionary or something very similar to a dictionary. Exactly, and we reference that by the key. In fact, the example that I'll show later today of using an external module will show something like that. Yep. All right. Yep, that's exactly why. I guess, so I think we've shown most of what I want to show with dictionaries. Basically, how to iterate through them is important. How to create them is kind of important, but it's not, we're going to mostly consume the data that already exists in this class rather than create new data. But we will have some examples to create, so it's important to show how to create them. Finally, the last thing that I want to show you about about dictionaries, is that the keys have to be unique. And you can actually add items to the dictionaries. So we could take my dictionary up here and try to add a new one. My last child, I could say equals, my dictionary Bryce equals 17. So if I run that and then reprint my dictionary, I'm going to have a new key value pair in here. You see that? I added it. Sorry, what's that?
Oh, now, when you say it was your birthday, could you change 44 to 45?
Yes.
You know, like, without redefining the thing?
Yeah, so I could, on April 11th next year, April 11th next year, I could do this, what you're proposing, and change my birthday. See what I'm saying? So I can reassign. They're not immutable. They're mutable. Dictionaries are mutable. I can change the individual values. They're much more like lists, but instead of using 0, 1, 2, 3, 4, 5, 6 to access them, you use the key to access the items in the list. Right. So, so I could,
But print, basically just say my dictionary and I'll essentially print it.
yeah, if you're using interactive Python or Python at the terminal window, yes, you just type the name of a variable and it's the same as typing print. It's shorthand. But if it's running as a script, then it won't work. It essentially skips that line. It doesn't print it for you. But it's shorthand. Also, it has to be the last item in the cell for it to do it. So if I did or what's the other one I created? Ing to span. I run this. It's only going to print ing to span. So it doesn't allow you to just like print everything. It has to be the last item for it to.
If you print both of them, you just hit both of them.
Sorry, if I print what?
If you went and print my dictionary and then print English and Spanish, you would get both.
Yes. And I'm pretty sure this will work too with the comma in between. Yeah. So with the comma in between, although it doesn't look like it, technically what I've done is created a little tuple that has both of these items in it. See how I know it's a little tuple? It's because it's put these little tuple parentheses on there.
So the dictionary can't have more than two references, the first and second part, because the
Oh, no, either the list, I'm sorry, the dictionary, the items can be anything. And actually technically the keys can be anything. That would get really confusing to ever do that. So your keys could be lists, but it would be silly to do that. The keys are almost always either numbers or strings. The values can be anything. In fact, it's fairly common to have a dictionary that contains dictionaries in the programming world. But it's you'll see here in a second that we can have a dictionary that contains a list. That's actually very, very common. So later when we get into accessing ArcGIS tables, we'll have an ArcGIS table is actually made up of dictionaries that represent the columns. And so when we ask for a column of data, it'll return it's actually going to return an array. There is a data type called an array, but we haven't discovered it. We haven't talked about it yet. Arrays are actually easier than lists and tuples because they're always the same data type. Every element in an array is the same data type. Yeah, go ahead.
I was saying like this George 44 place of birth, California.
Yep.
You have 3 items in that bracket, and you can still you get print statement within more than 2 items.
Like that.
Right.
So I'm going to call this. After what? Oh, right here. Yep. So now if I say my dict, I'll change that so it's not awkward. I get that. What data type is that, by the way? It's not a string. This is a string. April 11th, 1975 is a string. But what data type is this whole thing? It's a tuple. That's right. Yep. So that data type is a tuple. Now look, what if I did this? So you might, you might be wondering why you would ever have a dictionary of dictionaries. Well, this would be a reason right here. I gotta close that one. So now that's a dictionary. So if I want to get George's age, I could change this to say, and then put age. That's all right, age in there. Run that. So then it prints 44. Okay. Yeah, in fact, at this point, it might be good to show. This is one of the functions that I want you to use in the lab. It's called location.py right here. I'm going to copy this into a cell. And actually, I might as well create a new notebook. I'm going to create a new Python 3 notebook and just copy that in there. I'm going to rename this Raber George 4_1 since this is really the first assignment for today. For today. And I'm going to modify this slightly. I'm going to print what gets returned first. And I'm going to run this guy. So look at what was returned from this function. We'll talk in a second, we'll talk about why this function works. But look at the result of that function. Do you see all this? With that little notation right here, what got returned? See that squiggly bracket? What's that? Yeah, it's a dictionary. And it's a dictionary, and the dictionary has a bunch of stuff in it. The first thing that you can get is the spatial reference, and the spatial reference is of what type? What's this little squiggly bracket mean? Another dictionary. So the spatial reference is an item that itself is a dictionary. Candidates is the other item in this dictionary. See that? Candidates. Now what's candidates? Look at this bracket. What does that bracket indicate the data type is of candidates? A list. So spatial reference is a dictionary. Candidates is a list that's in the dictionary. And so what happens is in this function is that we've asked for the location of Hattiesburg, Mississippi, and what it's done is returned back the spatial reference that it's putting the response in, which is latitude, longitude, and it's given us a list of all the candidates for Hattiesburg, Mississippi. So the first one is actually Hattiesburg, Mississippi. The second one is Hattiesburg Street in Jackson, Mississippi. Let's see where the third one is.
So it's just taking keywords out of, like looking for Hattiesburg?
Yeah, it's...
And just all of the Mississippi is just picking them up?
Mm-hmm.
So where does that bracket end? Like you see all the candidates? Like is that the rest of it? Isn't?
Right, you see this bracket right here? Where does it end? It ends right here. I know that it ends right there, but it's hard to see where it ends. See what I'm saying?
I kept opening them. I couldn't find it.
Yeah.
The score is not ranking them. The score is just part of the list as a value.
The what? Oh, the score?
It's just a list value. It is not that it's ranking up in the program. It's already part of the list.
Yeah, so inside of this list, there's a bunch of dictionaries. See, this dictionary starts here and ends here. So every candidate record contains an address, a location, a score, attributes, extent, xmin, xmax, ymax. And then the next item in that dictionary contains an address. So everyone has the same. Every dictionary has the same items. Yeah.
Why is there not a Y minimum?
Why is there what?
Not a Y min? Like you have
There is a Y min. It's right here.
Oh, I didn't see it. Okay.
Well, how do you print them out in a list? Wait, is there a print, like, print them like, as if they were in columns and stuff like that? You print them a fresh list of all the songs, they're all the data like that?
Yeah. So I can do that. I'll show you. So here I'm just going to change this from printing it. So I don't want to necessarily see the result. So what I'm going to do here is insert a function like you want me to. Like so I'm going to call this make it pretty, maybe. Give it lock. So I'm going to create a new function called make it pretty, and it's going to get the result. Actually, I'm going to feed it just the candidates. Remember what candidates was. What is it? Oops, that's not what I meant to do. Control X. I'll just call this CAN for candidates. Maybe canned. Right. So for, I'll just say in candidate. I'll call this candidate. I want to print can. Sorry. So that'll return just the list. So if I just say print can here, I'm going to get each one printed out row by row. But if I want it printed a little bit better, I could then do another for statement and say for item in can, because can is a dictionary, say print can, or sorry, item, comma, can item. And then I'm just going to print a blank line here, so that in between each, I'll get a break. And I need to remember to do my parentheses around my print statements. It's the mistake I'm making the most. All right. So these are the candidates. I could even do another print statement at the beginning. Print and date. My print statement. Where did I mess up here? Candidate plus. Oh yeah, because I need to convert it to a string. One thing that we left out last week is actually the format function, but I'll talk about that some other time. All right, so see what I've done is I fed all the candidates into this function, and what this function does is it goes into the loop, and I have this counter. That's often a useful thing to do inside of a loop is to create a counter. And so it says for can in candidate, and it's just going to print the candidate plus the number. I might as well start at 1 because that's the way real people count. So I'll change it. And then it's going to get that first candidate, which itself is a dictionary. And so inside of the dictionary, I print out the item, and then I print out the key and the item itself. And then I have this values. Now we can see that there's still location. What data type is location right here? No, the data type for location. You can tell with the squiggly brackets. It's another dictionary, and it has two items, X and Y. So I could do something like this, maybe to add some formatting. So now they're kind of indented. Each one of them are indented.
But you said whenever you do the quotations, space quotations, that's giving you the indentation.
Yeah, right here. This is printing a few blank spaces at the beginning of the line.
What about all those zero, all the numbers ahead, like 8.9? You want to cut off the last three, cut off the rest after the last two numbers?
Cut off the rest after the last two numbers. There is a way to do that. Like I don't have everything memorized. So format, float, Python. So it looks like there's a function round. So I could say, so that would be this. Well, okay. So that might be difficult because this number right here, I don't even access that directly. I'm printing the whole line. And so in order to access that number directly, I would have to first check what's inside of it and then update it. Does that make sense? But I could definitely do that. Yeah, I'll show that later. I'm going to rename this because this is just another dictionary example now because we've modified it so much. Rename it. All right. So back over to here. Okay. So I had in here to do a quick. So we've basically done this part right here. I had in here to do a quick review of what we learned so far. So talking about programming, why it is, why we're doing it. The contrast between data types and variables. So a data type, every variable has a data type. That's an important message. Okay, even though Python doesn't explicitly require you to declare your variables as a specific data type, all variables have a data type. Okay. So when we make a statement like this, we've created a list. Like in a statement like this, we've created a string. It's implicit in the way you create the variable. So a statement like that makes a tuple.
So a tuple and a list are a type of variable.
Yes. Tuple and a list are a type of variable. All right. So most of the logic that comes into programming, one of the reasons that we're doing it is because we're trying to automate a task. We're trying to say, okay, I want to create this task. Well, the way that a program makes decisions is through applying logic, and that logic comes in branching and sometimes in looping. Like we can test a condition. That's branching using an if statement. If this occurs, do this. If that occurs, do this. And then looping allows us to perform a repetitive task over and over again for the same for the same, well, for similar data. Okay. Now, I guess in this example back here, we could probably put an if statement in here that said that if the item is a dictionary, then print out its sub elements, and then find out if they're if those are floats and truncate them to 2 decimal places. Definitely we could do that, but that would involve at least 2 sets of if statements and another loop for doing the loop through these guys. All right, we talked about functions. Why do we create functions? Functions are like little programs. There's basically 2 reasons that we create functions. But both could be summarized. Both of the reasons could be summarized as organizing our code. So one is to prevent repetition. If we find out that we're doing something in our code a lot, it's probably better to write a function so that we can just send it to a function, and if we need to change anything, we just change the function, and then we can reuse that function over and over again. The other thing is that it makes our code more readable, right? Like if I had all of this down here inside the code, people would have to read what's going on, and they'd have to interpret it. But because I've given it a label, make it pretty, I can pass that off to a function that will then do that label that I gave it, make it pretty label. So those are the 2 reasons, the 2 important reasons why we write our code, is because it helps an organization. The specific ways that it helps an organization are that it allows us to organize and label portions of our code, and then 2, it allows us not to have to repeat, which really cuts down on the mistakes that we make, because we can test just that function, make sure it works, and then we know it works, and we can move on with programming. So yes, in this case, there's a function it gets called, and then inside of that function, it calls another function. Okay, that's what happens. It happens a lot in code. All right. So just so you know, this is the part that I skipped, and that is creating our own classes. So a class is a way to create your own data type. So let's say you had a new data type that you wanted to create. You wanted to create a data type that represented a person, and that person was going to have a bunch of attributes. You could definitely create that just using a dictionary. A dictionary, some people would argue, is like an object notation thing. Like a dictionary is a way to organize a set of data into an entity. All right? The difference between a class that's and a dictionary is that a class, you explicitly define what all of the different attributes can be. So you say, okay, if I was to design a very simple thing like a point, I'm going to design a point class. What would be the attributes of a point if I was to make my own class of points?
X and Y.
Right, X and Y's. Those are the very obvious things, right? Now, what if my point represented a location in space? Are there any other attributes that I might want to give it? Sorry, what was that?
So the Z,
It could be. Yeah, the Z. Any other things I might want to give it? There's no really wrong answers here. Elevation. Did you already say Z? It's kind of the same thing, but what's that?
Like you need to know if it takes somebody to know like it's on Earth or a different planet or.
Right. Yeah. So we would probably just say the coordinate system that point is in. Yeah, because the coordinate system has a bunch of things to define, including the reference point. So yes. Right. So those are great examples, and you could just build a dictionary, right? We've shown that. I did that with my family with the George age. So it's a dictionary of dictionaries, right? You could do it with a dictionary, but oftentimes it's better to actually say, okay, well, a point has to have these things. It has to have an X. It has to have a Y. It has to have a coordinate system definition. Okay? Because with a dictionary, you can add and take away whatever you want in the dictionary. And you can't depend on it having the things that are dependent. And you could still make a class that has optional things. Like optionally, there's a coordinate system. If the coordinate system isn't specified, perhaps we're going to assume that it's a certain coordinate system. Okay. All right. So we're not going to deal with classes in terms of creating our own classes, but we are sometimes, just starting this week, and we'll get more and more, when we start interacting with other libraries, even with the ArcGIS library, there will be things that have been created from classes. So in other words, when we ask a row what the geometry is and it returns a value, it's going to be a point class of type point class. So the data type isn't going to be one of the data types we talked about, a tuple or a string or anything like that. It's going to be a point. That's the data type, it's a point. So an object is the name for something that's of a particular class. Okay, so the way to say that is like, to translate that into like real world, I am an object of the person class. So I'm a person, that's my class, and my particular instance of a class is an object. So an object is an entity that is of itself a person class. So yeah.
I just want to make sure I'm understanding this right. If, let's say you made a point class for a fire hydrant, so fire hydrant A would be the object. It would be an object inside that class.
Yeah, so the label that you give that fire hydrant that you create, it's a variable, and that variable is an object. It's not a plain old data type, one of the built-in data types in Python. Now that thing that you create could have that fire hydrant could have some attributes, and those attributes themselves could be plain old data types. So, one of the things could be color, and you could give it a string that represented what color it is. So that could still, your thing can still have attributes that are basic data types. In fact, it has to. In the end, the only real data types you have are the data types we've talked about. Okay? There aren't any more data types to talk about. So we've talked about numbers, integers. We talked a little bit about dates, but dates is another data type. We talked about floats. We talked about strings, lists, tuples, and dictionaries. So everything, if you want to make a more complex entity, it's made up of those other entities that we've talked about. Okay? And really, there isn't any more logic to talk about. Okay? There's loops and conditions are the things that you have to to build your process that you want to run. That's kind of why we're transitioning now. Well, that is why we're transitioning now into actually applying the language into using ArcGIS functions. Okay, the ArcGIS module. All right, now one other thing is that classes, they cannot just have, classes can have more than just attributes. We call attributes properties when we're talking about a class. So a person, like if the person was a class or the fire hydrant was a class and I created an instance, fire hydrant A or person A, I created an instance. Its properties might be something for the fire hydrant, might be its age, might be its color, might be how many spigots it had. You know, some have 2 spigots out one end, 2 spigots out another end, right? Well, objects and classes are used to create objects. These classes can also have what we call methods or functions. In other words, you can tell a class to have the ability to do something. So let's say with the fire hydrant example, you might have the ability to tell that fire hydrant to change color. In other words, you want to be able to change the color, and so you could have a function that's called color change, and it would change the attribute of that color change. And that maybe that doesn't sound that cool because you could just change the property, right? But let's say you had an attribute. Let's say you had a function that was called turn on, and it would actually turn the fire hydrant on. We don't have fire hydrants like that nowadays, right? You actually have to open them up. But maybe in the future, we'll be able to turn fire hydrants on from a central database. And so the turn on function would send a signal out to the fire hydrant, and it would start spraying water everywhere. Okay, that would be the example of a method that the fire hydrant class could have. Go ahead.
Like, we don't have the hydrants, but don't they have like things now where you can turn your lights on?
Yeah, exactly.
Concept, like what you're talking about.
It's exactly the same concept. So yeah, at home, I have a couple lights that are on a SmartThings sensor.
Yeah.
And so I can turn them on my phone. And so the person that's programmed that, the light switch is an object of class light switch. So my kitchen light switch is an object of class light switch, and one of the methods is turn on, and then there's another method, turn off. And so when they've written that code, they have the ability to turn those things on and off. Now, we actually have used some of these already without knowing it. So a string is actually an object. Let's see. I hate to make a whole new thing for this, but I'm gonna do it anyway. So object example. Right. So if I said my name equals George, right? If I say my name dot upper, you guys remember doing that? I run that. Oh, I didn't run this one. Sorry. Run that. There we go. So that dot upper, that's the notation that you use on an object, which is an instance of class string, to convert that string to, actually, does it convert it or just return it? I think it just returns it. I think we actually tested this last week. Yep, definitely just returns that value. Okay.
So George would be the object, and then the point upper would be a method.
Yes, it's a method. Exactly. So George is an instance. George is a string in. George is an instance of string that's an object, and it's a very simple object. It's a type string. Now, there are more complex objects than that, but I'm just getting at the point that that is an object and that upper is a method. Now, technically, all the sequences are actually classes, not simple data types. So the only simple data types are the strings, or sorry, not strings, the numbers and the dates. So all the rest of them, you actually can't. No, even a date is actually an object. So only numbers are the simple data types. They aren't objects. But every other object in Python, every other data type is actually an object. So we did uppers with strings. We did split with strings. Remember split? Here, I should do this as a separate one. My name dot split e. So that was another method on a string. All right. So as we get into different modules, they'll create different objects. And so it's helpful to go and review them. ArcGIS is actually pretty friendly. There's only a few other objects that it creates. So we'll talk about those. Most of the time we'll be dealing with basic strings or with some other data type that we're familiar with. But there are. What's that? Yes.
Okay.
Yeah, so that's the way that the dot notation is the way that you operate on a particular object. It's also the way that you operate on a module. You remember when we said import math before? Import math. We're importing the math module, and now we have it available. Well, math.sqrt is really giving us the square root of that. So math itself is a module, but even a module is a type of thing. So it's an object. That math, when we imported that math, it was, if we were to look at the code for the math module, it's just a bunch of functions. And so we've requested that the math, now it's an object. We can actually say we want to call it something else. We could say import math as MT, and then we could call it MT. I don't know why you do that, but it is possible. Well, I do know why you do that. I'll have to rerun this one. The reason that you might do that is, let's say person A had created a module called math, and person B had created a module called math. You could import them and call them different things, so it wouldn't be ambiguous. Math is a module, but once it's created, once we import it, we're treating it like an object, right? An instance of the math module. And this is one of its methods. Remember we had math.py? Okay, that is an attribute. That's an attribute of the math module. It's an entity we just pull out by name. We didn't have to put parentheses to get it.
It's a module, the same thing as a library. Others can change it.
Yes, a module is the same. In Python, they're called modules, but in a general sense, in other computer programming language, a module the general term is often used as a library. Okay. See, I could, yeah. I said I'd skip it, so I won't do it. But I was gonna, I could show you how I could create a little class that was a math module. So I could go class math 2, and then you can create that math2.py equals 3.14, and then you could create a function definition inside of it, and so on. But we're not going to cover that in this class. How to create our own modules. It's really kind of a more advanced topic. If we get to it, our own modules and our own classes. If we get to it, we'll get to it at the end of the course. Let's focus now on actually using these modules to do stuff. All right. So a module is just a group of code that does things. Okay. Oh, it is. Yes, I got 34 minutes or so. I'll plug it in. What is this saying? Every once in a while, Skype's flashing at me too. Okay, I'm plugged back in. So, as I said, modules, they're just a group of code that does things. They're often groups of functions, and sometimes they have, sometimes occasionally, like with the pi thing, they hold a value, a constant value that you can access for. But mostly, they're just a bunch of functions. Sometimes they hold the definitions for classes. So the module that we're going to start using today is called ArcPy, and it holds a few class definitions, like the definition for different types of geometries and things like that. Okay. All right. I guess I repeated that. I think I introduced the topic here, and this is where I was going to actually show you how to create it. All right. So we've already been using classes and objects. They're not something to be afraid of. We're going to continue to use them. Okay. We're going to be mostly consumers of classes and objects that others have written for this class. All right. So the first one I'm going to talk about is ArcPy. ArcPy installs with ArcGIS. So anytime when you install ArcGIS, it installs this module, and you can import it. So I'm going to go back over here and show you. So I'm going to save this guy and create a new notebook. We're going to call this, I'll call this ArcPy example 1. This is one of 2 GIS-centric libraries that actually install with ArcGIS. So there's actually 2 of them. ArcPy is for using on your local machine. The other one's called the GIS module, and it's for interacting with, like, if you want, you could use it to interact with ArcGIS online, or you could use it for interacting with a portal that you installed in your own system. And we will get to that, but we're going to start with ArcPy. ArcPy is for interacting with data you've got on your machine. So if you want to start interacting with data on your machine, you just put import ArcPy. And now you have ArcPy. Okay. What can you do with ArcPy? Well, there are a whole bunch of ArcPy readings here. And I'm actually going to click on them. So actually, that's not the one I meant to click on. I'm going to click on ArcPy first. Okay. Now, you'll notice that if you click on ArcPy, there are, when you're in the help here, if it says ArcMap 10.7, then you're dealing with ArcMap. And we want to deal mostly with ArcGIS Pros. I'm going to fix these links. If you hit Arc Pro, it'll take you to the Arc Pro version. So yeah, I got to fix those links. I'll fix that. Thought I fixed most of them. So here's the Arc Pro help on the thing. So we can import ArcPy. Once we import ArcPy, we have the ability now to perform GIS functions. Okay? The help for ArcPy is actually pretty good. Unlike, I think, because Python is community supported, and so sometimes it's hard to find the help you want. I often find it's easier to just Google things in when I'm trying to answer a basic Python question, because somebody out there has put the answer up. But when I'm doing something in ArcGIS, I often find that it's best to reference the help. And sometimes I still use Google, but I make sure I put the word ArcPy or ArcGIS, and it usually takes me to the right answer. So here is a very simple script that shows you how to use ArcPy to do a clip analysis. So you can see that ArcPy itself is a module, and the clip analysis is a function that's inside of the module. Every single tool that's in the toolbox is a function in ArcPy. So, and that includes even tools that you create on your own. They can be accessed through the ArcPy module. But what am I talking about here? Let's go ahead and open up Arc. I think it's, when you're programming, when you're writing Python code for ArcGIS, it's often helpful to have ArcGIS up so you can see the results and make changes and go back. All right, so I'm going to just create a new blank project. I'm going to call this Lab 4. I'm going to call it Lab 4 underscore SPA, so don't get confused with my other class, because I think I do have a lab. Yeah, I already had a Lab 4 over there. Okay. So what I'm talking about here is if I go to analysis, I hit the tools. Everybody here has probably run a tool in our toolbox before. Okay? But every single tool that's there, if I want to do a union, that's under the analysis tools. I can open that, and then I can go to overlay, and union's right here. And I can hit the little help icon. Once this shows up, there'll be a help icon. This help icon right here. I can hit that help icon, and in every single tool, there is an example of how to use that tool use in Python. So here's an example of doing a union analysis in Python. And then sometimes there's actually a longer example that might show an application. In this case, there is. So we've done that sort of thing. All right. So that's how we run a certain. That's how we do that. Let's go ahead and actually try to run one of these tools the way they're set up in, or the way that they're shown in here. Okay. So to do that, I'm going to download the data for today's lab, and I actually already have it downloaded, but I'll just download it again so that you can follow along if you want to follow along. So you go to SPA, go to week 4, and I have a file in here called labdata.gdb.zip. So if I click on that, that individual file itself, I can hit View Raw. Just wanted to make sure everybody knew how to do this. And if I hit View Raw, it actually downloads that file for me, just that file. You could install you could also install GitHub on your desktop, and you could download it, but I think this is a lot easier. Okay. I mean, not a lot easier, but this is the way to just get a single file. So now I'm going to open that file, and I'm going to copy it and put it somewhere. I'm just going to put it in temp, paste it in there. I already pasted it there before class, but I just paste it again if I wanted to paste it. I'll just paste it again. So now I've pasted the lab data. I should have called it like lab 4 data, but I didn't. So there it is. It's just a, what file type is this? Yeah, it's a geodatabase. I really wish I could figure out how to turn the volume up. Okay. All right. I think let's give everybody a chance to download that if they want, and then and we'll take a break here and come back at about 1:15. I'm just gonna bring this data up inside of ArcGIS. So I got it right there, and I added it. So if you get to this point, you'll be all set. And I'm going to have a little break. Again, today I have to leave around 3, so we'll take our break right now, which is a little bit earlier than usual.